Welcome to this lesson on RDS Instance Classes and how to size your database for optimal performance. In Amazon RDS, choosing the right instance class is crucial for balancing performance and cost. Throughout this lesson, you'll learn about different instance types and how to select the one that best fits your workload requirements. Instance classes define the compute and memory capacity combinations that determine your RDS database performance. Think of them as the hardware specifications for your database server. Each instance class provides a specific amount of CPU power measured in virtual CPUs, memory, or RAM for caching and operations, network performance for data transfer, and EBS optimization for storage throughput. These resources work together to handle your database workload efficiently. Understanding the naming convention helps you quickly identify instance capabilities. Every RDS instance class follows a structured format. It starts with the prefix DB for database, followed by the instance family like M, R, or T, which indicates the type. Next is the generation number, such as 6G or 7G, representing the hardware version. Finally, the size like 2x large determines the capacity scale. For example, db.m6g.2x large is a general purpose, 6th generation Graviton instance at 2x large size. RDS instance classes fall into three main categories. General purpose instances, represented by the M family, provide a balanced ratio of compute and memory suitable for most workloads. Memory-optimized instances, using R or X families, offer higher memory to CPU ratios designed for memory-intensive database operations. Burstable performance instances, marked with T family, are cost-effective options with baseline performance and the ability to burst when needed. Each category serves different use cases and budget requirements. General-purpose instances with the M family designation provide balanced compute and memory resources. These are ideal for web applications that need consistent performance, medium-sized databases with moderate query complexity, development and testing environments, and workloads with moderate transaction rates. They offer the best price-to-performance ratio for typical database workloads where neither CPU nor memory is the primary bottleneck. Memory-optimized instances, using R or X families, feature higher memory to CPU ratios. These instances excel at running in memory databases that keep large datasets in RAM, high-performance analytics requiring fast data processing, large caching workloads that benefit from extensive memory, and real-time processing applications. Choose memory-optimized instances when your database workload is primarily constrained by available memory rather than CPU capacity. Burstable performance instances, marked by the T family, operate on a baseline CPU performance model with the ability to burst above baseline using CPU credits. They are ideal for development and testing environments where consistent high performance is not required and low-traffic applications with occasional spikes. These instances accumulate CPU credits during idle periods and use those credits when burst performance is needed. This makes them highly cost-effective for workloads with variable CPU usage patterns. Instance sizes scale resources proportionally within each family. Starting from small with one virtual CPU as the baseline capacity, each size increase doubles the resources. Large provides 2 virtual CPUs with twice the resources. X large offers 4 virtual CPUs with 4 times the resources. 2X large delivers 8 virtual CPUs with 8 times the resources. And 4X large provides 16 virtual CPUs with 16 times the resources. This progression continues, with each size doubling increasing virtual CPUs, memory, and network performance proportionally. Understanding this scaling helps you predict performance and cost as you move between instance sizes. Selecting the right instance requires evaluating several factors. First, analyze your workload type to determine if you need more CPU power or memory capacity. Consider your traffic patterns, whether your workload is consistent or has burst requirements. Factor in your budget constraints to balance cost with performance needs, and think about your growth plans and future scaling requirements. A best practice is to start with a smaller instance size and scale up based on CloudWatch metrics. This approach helps you avoid over-provisioning while ensuring adequate performance as your needs grow. Let's recap the key points. First, choose your instance family based on workload characteristics, whether you need balanced, memory-intensive, or burstable performance. Second, general-purpose M instances work for balanced workloads, while memory-optimized R or X instances are for intensive operations. Third, burstable T instances save costs for variable workloads with occasional spikes. Fourth, remember that instance sizes scale resources proportionally, making it easy to adjust capacity. And fifth, always monitor CloudWatch metrics to optimize your instance selection over time. Right-sizing your RDS instance ensures optimal performance and cost efficiency for your database workloads.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.